All right, question 4, we'll kind of answer some of those questions about assigning oxidation number, assigning charge. And so in this case, it asks us in which reaction does the oxidation number of hydrogen change in question 4? And to answer this, yeah, we have to assign charge. We have to basically figure out, is this a redox reaction or not? And to do that, to figure out if it's a redox reaction or not, we have to assign charge and figure things out. So, for example, this first one, if we ionize everything in the first reaction, we get H plus, right? We know hydrogen's always +1. Chloride is -1 because it's a halogen. Sodium's group 1 metal, so that's +1. And hydroxide is -1. And then we get NaCl. Sodium is still +1 because it's still a group 1 metal. Chloride still -1. And water. Water is molecular, so there's no charges, but we can assign charges to it if we'd like. And so we can break up water into 2 hydrogens and an oxygen. The whole molecule is neutral, has 0 charge. Oxygen is always -2. So that makes hydrogen +1 each. And so if we take a look at this reaction, right, it is not a redox reaction because hydrogen is +1, it ends up as +1. Chloride's -1, it stays -1. Sodium's +1, stays +1. No oxidation state changed here, right, for that first one. We'll skip the second one for a bit, and we can do like the third one here, C. Do the same thing, right? We can split this up. Even though it's a solid, we can treat it like it's ions in solution to just assign a charge. And right, calcium would be +2, oxygen would be -2. We would split water up the same way. So we'd have 2 hydrogens at +1. We've got oxygen at -2. When I form calcium hydroxide, same thing. Calcium is still +2. And then the hydroxides are -1 each. If I take a look at hydroxide to further assign charge, we would split it up and see that hydrogen is +1, oxygen is -2, and that's where the whole thing has a charge of -1. But again, when we look at this, calcium started off as +2, ended +2. Oxygen's -2, ends -2. Hydrogen's +1, +1. Not a redox reaction. We can do the same thing for the rest of these, and we're going to see that there's not a redox reaction. So in D or E, one good sign of a redox reaction is anytime you have something that is a pure elemental solid and it ends up as aqueous. Or if it's aqueous and ends up as a pure elemental solid. That's typically letting you know there's a redox reaction taking place. So here, sodium is 0. In the water, right, we've assigned the charges to water previously. So I've got hydrogen that's +1, I've got oxygen that's at -2. And then over here in sodium hydroxide, sodium now is +1. So there's a redox reaction, right? Sodium went from 0 to +1. Hydroxide, we can assign charges to like we have. I've got +1 for the hydrogen, -2 for the oxygen. And then when we get over here in hydrogen gas is 0. There's 0 charge assigned to hydrogen gas because it has to be neutral. And then each hydrogen, there's no charge because it's 2 of the same elements bonded together. So this is our redox reaction because I've got sodium going from 0 to +1. We've got some of the hydrogen yes, some of the hydrogen stayed the same, but some of the hydrogen went from +1 to 0. So this is the only one that's a redox reaction, right? Like I said, the good marker to look for a redox reaction is, do I have elemental solid becoming aqueous, or do I have something that's aqueous becoming an elemental solid? That only happens through a redox reaction. All right, I'll do question 9 now. All right, given the following reaction, if you have, okay, yeah, so limiting reagent calculation, all right, given the following reaction, if we have 5.62 moles of ammonia, yeah, Molly, all elemental solids are going to be 0, and then any diatomic would also be 0. So like chlorine or nitrogen or hydrogen, all of those we would assign 0 charge. Number one, the molecule has to be neutral because there's no charge on it. It's not an ion. And then number two, if we were trying to split it up and assign a charge, right? Like we did this with water. We split up water and said, okay, I've got 2 hydrogens and I've got oxygen. I know oxygen is always -2, and we know water carries no charge. So I need a +2 here. So each hydrogen is +1. We can do this in water because it's different elements, and we can assign and call oxygen negative, and that makes hydrogen positive. But when we have hydrogen bonded to hydrogen, and we know the whole thing has to be 0, right? It doesn't make sense to say one hydrogen's positive and one hydrogen's negative, and then together they're 0. So we just say that they're both 0 charge because they're identical elements. It wouldn't make sense for them to have exact opposite charges. So yeah, any diatomic is 0. Any pure elemental solid is 0. 6.17 moles of oxygen, and what are we looking for? We're looking for moles of water. How many moles of water? So we know for every 4 moles of ammonia, 6 moles of water, and for every 5 moles of oxygen, 6 moles of water. So this one we actually should do the calculation for, because based on the mole ratio, we should need a little bit more oxygen than ammonia, and we have a little bit more. So these numbers are actually pretty close. So 5.62 times, so potentially, all right, potentially when that cancels out, we get 8.43 moles of water, and then down here, 6.17 times 6/5. Yeah, we get 7.4 moles of water. So it looks like this would be our limiting reagent, the oxygen's limiting reagent. When that runs out, the reaction stops. The reaction stops at 7.4 moles of water. So limiting reagent calculation, definitely something like this on the exam, right? It's fair game. This one is a little bit easier because it's just mole to mole, right? The ones we did in class, grams to mole to mole, and then moles back to grams, a final product that we can make. Any questions on 9? I'll go to 11 next, and then we'll take a break there, and then yes, 11. Question 11. We will do some redox reactions, yes. Yeah, I think I just need to remake question 11 and make it like a matching or something. So I think part of the problem is putting in the blank, right? Filling in the blank. All right. How to see this as a redox reaction? We're going to break iron 3 oxide up into 2 iron and 3 oxygen. Oxygen is always correct. Limiting reagent is always going to make the least amount of product. That's what runs out first. Yeah. So oxygen is always -2, so that's -6. The whole thing is neutral. I need a +6 from iron. I've got 2 irons, so each iron is 3+. So I've got 2 iron at 3+, and it ends up as 2 iron. It's an elemental solid, so it ends up as iron 0. How do we do that? Right? It's going to gain 6 electrons. So the reduced species, right, would be Fe2O3. That would work. Or if you said iron 3 oxide, that would be acceptable. Trying to think what else I typed in there. But I think even if you don't do the subscripts, even if you do like Fe2O3, it should take that as well, because that is gaining electrons. So by default, what is being oxidized must be the other species in the reaction. So we can take a look at that. Carbon monoxide, if we split carbon monoxide up, oxygen is -2. The whole thing is 0. So carbon needs to be 2+ in carbon monoxide. So carbon dioxide, same thing. Carbon, 2 oxygens now. So the total charge is -4 from oxygen. So that means carbon must be 4+. So the other reaction is carbon 2+ goes to carbon 4+. How did it do that? Right, it did that by losing 2 electrons. So that's the oxidation reaction. Right, so reduction, oxidation, right? Remember, whatever is being oxidized becomes more positively charged because we are losing negatively charged electrons. So if you put like CO up here, right, carbon monoxide, that should work as an answer. All right, oxidizing agent and reducing agent is a little bit tricky because where the name is from. Right, the name is the opposite of what it's doing. So oxidizing agent causes oxidation, right? Causes oxidation, but the oxidizing agent causes oxidation, it gets reduced. So it's the iron, whatever you want to choose, whatever choice you want to go with here. I think even iron would work as an answer. The reducing agent causes reduction. It itself gets oxidized. So the carbon monoxide, either one of those should work for question 11. And yeah, I think either the next time if I do this, I'll either make this like a matching question, or maybe I'll somehow make it a little bit easier, because I think part of the challenge was just like one student emailed me not sure of what to actually type in the blank. Was I looking for the element or the molecule? Yeah, it's just one and the same, Ty. Yeah, I should have just said, what agent or what element, just to make it more specific. Um, so oxidized and reduced. Oh, the oxidizing agent, right, causes reduction. And the reducing agent, right, causes oxidation. So they're named for what they do. The opposite happens to them. And then for the charge on carbon, yeah, we up here, right, we get carbon as 4 plus in carbon dioxide, because in carbon dioxide, there are two oxygens. Oxygen's always -2, so that's -4 charge from oxygen. The whole thing is neutral, right? There's no charge assigned here. So in order for this to balance out, carbon must be 4 plus. And again, this is just an assigned charge so that we can see this as a redox reaction. It's not ionic, but we can kind of treat it like it's ionic. So we can assign an oxidation state here to see what's happening in this reaction. Yeah. Any other questions on 11? All right.